So we should be live both on Twitch and on YouTube, if I'm not wrong. So let's see. Double checking for live. Welcome to the stream. Anyone who is joining, we're waiting for people to drop in for the stream next couple of minutes. Then we will kick it off. And anyone who is already here, I want to welcome. We are building the 3D printed computer case. We're building a computer using that. Hello, hello, Tutum Carmen is already here. So this time I'm offering both options. I am streaming on Twitch and also on YouTube at the same time. And we'll see how far we come. I think we have a realistic chance to finish this build today because I've prepared almost everything. So there is probably nothing missing. And if there's anything missing, I can also grab the tools. So everything is here and find the stuff, hopefully. Who is here? Tunkai Ayan is here. Hello, hello. People are slowly dropping in. I guess we're waiting just a few more minutes to start. So on YouTube, we already have 11 people watching. How about Twitch? There is, yeah, Twitch is probably not many people are using Twitch because it is the first time I'm using it. So today I'm streaming both on YouTube and on Twitch. On Twitch, the channel is called Daniel Crosslink, and I'm just testing out whether one or the other works better. I think it's we're using Restream.io, so we basically can stream to both platforms, hopefully without any quality loss. And what's the idea of today's stream? Briefly explained, I think it was 8 months ago when I introduced the 3D printed computer case to everyone basically on the YouTube channel. I made a video about this. I was working on a customer project and made a custom PC case. Now, over the last couple of months, I have finished that project and I have modified the case further and further, made some changes based on the suggestions from the community. So there was a few comments on that video, and actually just last week, that specific video got a lot more views. So people were, for some reason, discovering that video and were adding more comments. And when is this thing going to be available? So the plan for today is that we're going to finish this build, testing out if the new version is working as I expect. So we're going to go through all of the parts and the things that are required to build it and to assemble it, and gonna show you everything that I require to do this. I'm gonna take pictures while I'm doing it because I want to document it also for printables.com. So I will take pictures and then we're gonna push the pictures to printables.com. I already uploaded the STL files for this latest version. So then I can upload images and then finish the upload and then publish it. So at the end of the stream, hopefully we're gonna have it published to printables.com. If we encounter any problems and something's not working, then probably I have to make some adjustments. Still, I wanna push out this thing as soon as possible. So my hope is that it's going to be, yeah, nice to see more people streaming instead of doing videos. Yeah. So I hope that by the end of this stream, we're gonna have it also published so everyone can download. Briefly, talking about what is this all about? What was the idea? So the idea was to create a 3D printable computer case for an ITX mainboard. So if you know, this is the form factor, ITX. It is a This is the smallest PC mainboard form factor that is on the market, and therefore you can build pretty small cases. So let's show it here. Just giving you a little bit of an overview of what the parts are. So this is the main board. It is in this case it's an Intel main board. I think it's an i5 processor, so something that's not too expensive and it's also not consuming too much power. And then the question also, some people ask, like, how can you get power into this main board, or how can you power up this main board? And you can, of course, use an external power supply, but in this case, we're using something that's called Pico PSU or Nano PSU. So if you look on Amazon, this is basically just a little plug that goes into the power inlet for the mainboard. And it is capable of running this mainboard up to 150 watt. And then there is an external power plug where you plug in an external power converter to supply this all with power. So this goes into the bottom of the case. I've shown you that in the previous video, but there was a few things that I wanted to change. So let's walk briefly through the parts. The first part here is the bottom element, which is where the computer case is standing on. And also this is the mounting plate for the mainboard. So we have a mainboard mount that's very minimalistic, but still doing the job pretty well. So surprisingly sturdy. And that's going to be mounted on top of this base plate. Yes, it is ITX, and it needs a chrome tailpipe. Yeah. So this is the mainboard mount. It goes. It will be mounted and fixed onto the base plate. So let's move stuff a little bit so we can see it better. So here we go. So base plate, mainboard mount, and then mainboard is vertical mounted. Optional, you can use optionally you can use either a double slot SSD mount here on the other side, or just a single slot SSD mount. I've put both things on printables, but that's just optional because this mainboard has an onboard M2 SSD, so you theoretically you just don't need an additional SSD. In my case, I have an additional 1 terabyte for storage, but you can also just leave that out, or you can use a 2.5-inch 5 terabyte hard disk if you want to build a network storage, or you can also, I think we can also theoretically we can also build a 3.5-inch mount for something like a 16 terabyte hard disk. But that's probably also something where you have to look for it, like, is the power supply capable of running all of that? The motherboard mount looks like an antenna, yeah. So then the next part that goes on top, so as soon as you've mounted the mainboard to this base plate, to the standing plate, the cover comes on over it. So there is a version of this cover. This is the version with the smaller slot here. So normally you have I/O ports, and these mainboards usually have, yeah, depends on the mainboard, but this specific mainboard has a flat surface. So the I/O panel is completely flat. That's why I created this version in the first place. So this cover, or this body part, is just going over the front plate here, over the I/O panel, and it's just touching the surface, and it's a little smaller, so it is really just going around the inner border. So it's partially, like, it's slightly, sometimes depending on whether the mainboard is completely vertical, it might have, or it might be that you have to push a USB port, for example. You have to push it a little bit to get in, because it's really very close to the port, so it just goes around here. That was the reason why I created another version of the body that supports any kind of I/O panel, because other mainboards, the cheaper ones specifically, so this is more an expensive mainboard, and don't ask me why, the cheaper mainboards use a detachable I/O panel that has a pretty thick border. So that's the standard I/O panel, which you normally have to click into your case first, and then you push the mainboard through. And that's because there's a lot of these cheaper but mainboards with the standard I/O panel. That's why I created a new version of the slot, which is bigger. So it is definitely a bigger slot. It also goes a little bit further down. So yeah, what's left here is a little less. So I decided still to keep it, not to make it larger in this direction, but it supports the standard, any standard I/O panel. And then you just push that in. Probably first push the I/O panel in here, fix it with some tape so it doesn't fall out, push it over, and then like adjust the mainboard. But that's basically, the choice is up to you which one you want to use. Depends which mainboard type you have. So with the flat panel here, I personally prefer the smaller slot, but it's both are working fine. So again, when this is all mounted, you have it sitting on top of it, on top of the base plate. You screw these two parts together, and then the next part is what is it? We have a few more people joining. What material am I using? That's pretty much very flexible because PLA works fine. We've printed, I think now 60 pieces, and the PLA version works just fine. I can imagine, like, depends on whether you're like have to ship this or if you want to send this around. Using PETG might be a choice, at least for the mainboard mount, or ABS or ASA to make it more sturdy. But so far, which is the interesting story, none of those broke yet. So it's pretty stable. And it's probably also like there is PLA and there is PLA, right? So not every type of PLA is equal. There's different types of PLA. There's PLA Plus, which is pretty rigid. So I wouldn't say that you have to use a certain material. So you don't have to use PETG. You can use PLA. And if you think it's specifically the mainboard mold is too wobbly, you can still use something else. But like the body part is not something that has to carry a lot of weight. So it's not mechanically under load, so to say. It's just a shell. And that's why you can pretty much use PLA for most parts without any problems. Then the next part, that comes here, and it's sliding inside of the body. And there's a little border that's going to be left. And this fulfills two purposes. First of all, it is a mount for a case fan. So the case fan will be mounted to the inside, right? It's going to be screwed into this part, and then it's going to come into, like, it's going to slide in here. And this is, first purpose is, of course, to transport the air out of the case, to have the air circulating. And the second purpose of this part is that we can, optionally, if you want, you can insert an LED strip. And there's a little slot here around this part. That's also the reason why I printed it in transparent PLA. I mean, it's not exactly transparent, but it's transparent enough so you don't see the LED strip, and it's still, the light is still going to be transported to this outer corner or this outer edge, and you can see the LED color. We'll see that hopefully today. And then the last part that goes on top here is the grill, as I call it. And the grill, or the top cover, comes on top. And that's, you see here, that's what's left of the LED fan ring, just very tiny border here, and you will see the LED color. So if you want to use the LED in this top part to show some status message of the computer, or just want to have it fancy, glowing up fancy, or having color change, what the mainboard may be supporting, up to you how you use that fan ring in terms of LED lighting or not. You can also just print it in black and not use an LED strip. So it's totally up to you how you use that. The last part is available in 2 different versions, and you see why. First version is completely closed, except the grill, which is going to let the air out. So the air is coming from the fan, it's pushing against this part, and then it's going out sideways through the grill. And the second version is basically looking almost equal. The only difference is that we have a hole here in the top, and that's where we're going to insert the power button. And in the first version, so this is the power button. It's just a little button which is also LED, has an internal LED, so it's going to light up as soon as the computer turns on. And in the original version, the first one that I've used, this button was in the bottom element, so you couldn't see it, and to reach it you have to basically tilt the case and reach it with your finger and turn the computer on. And I didn't like that too much, and the comments also suggested that why don't we put this in the top element, just in the middle, so we have this sitting right in the middle, and then we can just turn it on and also see the LED of that button. So that's the other version. And the cable will have to go sideways to not conflict with the case fan. So it's like, that's also the reason why we have this cutout here in the middle, so you can reach the screw, so you can fix it, and then you can run the cable to the side. The cable will go through this little slot here around the fan and into the main body, where it has to be connected to the main board. So the challenge there is like, how is this going to be assembled? So which order is the right order to do this? We'll see this in the course of this live stream. So we have some questions here. Total print time. Last time when I calculated the print time, that was with the Ender 3s. And then I think I had around 80 hours for the whole thing. So around about probably 3 days. But it was very conservative settings, very slow. Why? Because this material, this specific type of PLA is pretty, what I don't like about this is if you print this faster, it's gonna get, like, it's not as shiny anymore. So that's why I slowed down the print speed, because I had very inconsistent reflectiveness. So you can see it here, this was printed faster, but you can see it is not totally consistent in terms how it looks. So that's why for a prototype this is totally fine, but if you want to print it for like the final thing, you want it to be like a more consistent shininess, and that's why I printed it slower. So that's the effectively the problem, like maybe just with black material, and it's like if you have something that's supposed to be matte, this might look different, but this one's supposed to be shiny, and then when you print it too fast it gets rough, and that's why it doesn't look consistently shiny. So the same problem with the top. To get this perfect, this is also just a prototype version, but the final print, the idea is, of course, that it looks all consistently the same. And to have this looking perfect, you have to go very slow with the top surface. And I did, like, this one is like basically just lines. And then for this other version here, I've decided to print it with a circular pattern. So this is just circles. And this other one was just lines. And this doesn't look perfect. So you see, same problem here. This is not a problem with the printer, but this is more a problem of print speed, right? So material gets a different touch depending on how fast you print that. So you have to test it out, or you just choose something that is probably not that critical. If you choose a material that is very forgiving in terms of surface reflectiveness, or multicolor material, or like maybe it's just this type of PLA. Other materials might be very forgiving in terms of how much you really see of that kind of problem. Anyways, let's come to the chat questions. As I said, print time 80 hours, roundabout with the Ender 3 with the Bamboo Lab. I still printed quite slow, so I changed the Bamboo Lab's default settings to go, I think, 50% speed, just to get more consistent result and higher quality. And still it is half the print time of the Ender 3, so you can probably get down to like about 40 hours for the whole thing. But yeah, I think the longest print time is for this body part, because that I printed quite slow. The other ones aren't that critical, except the top part, which you will definitely see if you go too fast. And but I will include some print recommendations in the printables documentation. By the way, one suggestion that you made in the last video, and I took that, I think that was probably one of the most important comments. The bottom element is where the air enters the case, and the grill is where the air comes out. So the problem with that is you will suck up all of the dust from this side. And without any filter element, you will have, probably at some point, you will have a pretty dirty mainboard, and dust is going to settle depends where you are and how much dust you have in your rooms. It's going to be more or less faster or less quickly filled up with dust. So the idea was, why don't we add a filter? And the first version that I had of this bottom element, which basically I wouldn't use anymore, there was no space for any filter, and I had to change a few things. So in the end, what I decided, because I couldn't make it work, completely redesigned this element, made it completely new from scratch. And that's where this filter comes in. This is a pretty standard 120mm fan filter, which you can buy anywhere for a PC. And this filter now is going to be attached to the bottom and going to be filtering out most of the dust. Of course, not everything, because smallest dust particles will still pass by, but at least it is an improvement. It's probably very significant. And then you can just screw that to the bottom. This filter specifically also has magnets, which I can't use at the moment, so it can be screwed in, or you can, if you have a metal case, these 8 magnets will attach to the case usually. The idea could be that we insert some kind of metal screws or something as counterparts to these magnets. We'll test this out, but for now it's just fixed with 4 standard fan screws, which are coming with the filter anyways. So I think that's also one of the first things that we're going to do when we mount this all together. So, hey, Filament Stories is here. Hi, nice. Thanks for joining. We're building a computer case today, or we're building a computer today. For anyone who's late joining, so this is all the things that we need today. We have 3D printed computer case elements, and this is the main board, so this is the heart of the computer. I've already installed operating system on this, so this is pretty much ready to go. Just needs to be connected to power, and that it should be working. And let's see if we have any more questions. Temperature. Temperature, doesn't PLA come soft when the temperature goes up? Well, PLA has some kind of a melting point, or it gets softer at some point. So anything above 60, 70 degrees, it can become softer. It can start to become soft, and that's something that might happen if your computer runs very hot. But as this is a very low spec computer, it's an i5 processor, and we have a fan for the processor, and we have a pretty big case fan. I've tested that already with the old version, and again we have now over 60 of these computers in the field already, so 60 real world real world pieces of this are out, and so far nothing has broken, nothing has melted, but it's actually AMD processors in these other computers, but it doesn't really make a huge difference. Basically, low spec. It is not a high performance computer system because you cannot. The one thing is the downside of this design is, of course, it is very tiny, so the inside doesn't really have enough space for an additional graphic card, so no GPU. I have an idea how this could be done, but I mean, if you have an Intel processor and you have a more expensive mainboard, which this is also one of the cheaper ones, still the more expensive mainboards have Thunderbolt ports which you can use to attach an external GPU case. That could be an option. Then, any more questions? Get a bit of polish. Yeah, well, I mean, we could also, like, finally, what was done for the customer version of this, actually this the color of this, or the perfection of the outside of the shell, didn't really matter. Why? Because what the customer decided is to do to cover this whole thing up with a shell of cloth. Basically, it was like it was tailored specifically to fit on top of the case, right? And there was also different versions of these bottom and top elements. So these are like for this covered version, which gets this additional outside shell. The top and the bottom are a little bigger, so in the end it's going to align perfectly with this additional shell that's going to go around. That's made from, I don't know, was it silk or some kind of cloth that is basically just tailored and then fitted. I think it's glued on top, or don't know exactly how it's fixed, but I think they are using glue to fix it. So that's why for that series, basically didn't matter how it exactly looks, if it's perfectly. But I have an idea. We could also use some fancy material, like this one here. And I think filament stories, you know, these like dual color filaments, and this from 3D Jake, for example, Magic PLA. I can imagine that by using that kind of material, you don't see any of these problems anymore. And my experience with these kind of materials is that they are not that dependent on the print speed. So the outcomes are not going to be so much depending on the print speed. I think this one is a pretty cheap PLA, and that's probably also the reason why this print speed makes it show more or less shininess. So let me see, how is the stream going? Since this is today also a little experiment in terms of what we're using to stream, I'm wondering if the stream quality is good, or if we are having any issues. So let me know if anything goes wrong in terms of the stream quality, if it gets stuck or if it's jittering. Just give me a hint in the chat. So next step here, or one of the first step actually, what I want to do now is start with the bottom element and fix the fan filter, and that's done by using the standard fan screws and just fixing that as the first step. And again, I think the magnets on this filter, some of these filters might have magnets. I think we can think about a next version of this where we have some option to use it, to use the magnets to attach it to the bottom instead of using screws. That may make it a little easier to clean the filter, so to dust it off. But I think in general you just can come with your duster, just hold it above and then get it cleaned. Should work. Next thing here is, for now you see, how is this all mounted together? I think I didn't talk about that yet. I'm using a brass threaded inserts for mounting most of the pieces. So in this mainboard holder I already have these 4 M4 threaded inserts. Since this is a fresh print, I will have to insert the threaded inserts right now. So I have a special adapter for my soldering iron. So there is threaded insert tips that you can use on a standard soldering iron. And the good thing, instead of if you're using your standard tip, it will be a little more difficult to align with the threaded insert or to keep it vertical. And with this special tip here, I'll give you a closer look. With this different tip, I don't know if you can see it, with this new soldering iron tip, it is much easier to put the threaded insert just over it and then push it in. So it's always going to be vertical and much easier to use than with the standard tips. It's a little dark. The stream is dark. The strange part is that I have 2 monitors here, and on one monitor it's actually pretty bright. on the other one it looks pretty normal. But yeah, hopefully not. Hopefully it's not really dark. So, heating up the soldering iron, I am using, I think I'm going to use something like 250 degrees. And then we're pushing in the first few threaded inserts here into this case. Bottom. So, how does this work? I think 230 is fine. So, I'm taking the threaded insert, I'm just like putting it on top of the first hole. And the threaded inserts have 2 sides. One is a little smaller, and the smaller one goes in first, so you can push it in a little easier. Just have to align that. Then you come with your soldering iron and just push it in. And you basically just wait until it starts melting the plastic and then slowly going down. And the only thing that you have to be aware is that you have to hold the soldering iron perfectly vertical. So because the thread, otherwise the thread is not going to be vertical, and you're going to have a harder time inserting your screw. So this should be enough. And it's like you can easily touch it with your finger and see if it's in, but it's pretty much perfectly aligned with the surface. And we do this 5 times. We have 5 mounting points. 3 are going to be for the main board. I'll show you in a second how this is assembled once we're done inserting the threaded inserts. So number 2 is going in, and this looks good. Can probably zoom in a bit, you see more. So, hope this is sharp enough. Yeah. So number 3, so these are like the 2 points for the main board mount, and a last one. that is actually something that I probably will change in one of the future versions of this bottom element. I'm not really happy about the positioning of the third one. I will, my idea is probably that we were going to change. I will show you what my final plan is for this. So this one is done. So the idea is we have 3 mounting screws, 2 at the back side, and then we have a third one here in the front that's going to be holding it so it's not going to tilt. My idea is that I'm going to add another one here and another one out here, because originally the case was a little smaller, so the diameter was smaller, and that's probably also yeah, that's the reason why I designed it this way. But now I have a little more space, and I can move these 2, or at least I can have 4 screws in the end. 2 on the outside and the front, and 2 in the back side. I think that's also that's going to free up this this element here, so this section of the grill. So a little more airflow will be possible. I think it's just going to look a little cleaner. But like functionally, it's currently working fine. But it's just a tiny detail that I want to change. But it doesn't really matter. I think it still works fine. So Porphyrios is coming into the stream. What questions do we have? Today, I'm not going to answer questions about Marlin firmware in this stream because I want to focus on this build. Sorry for that. We can talk about that in a video, in a stream about firmware factory probably. I plan to do one next time, or one of the next streams. I want to do a firmware factory stream where we go through a few sample configurations. Today we want to focus on this build because I want to get it done. I will insert last 2 threaded inserts right now. The only thing is I probably will have to make these holes just a little bigger so we can insert the smaller end easier. I was just a bit afraid if that might affect the rigidity of the whole thing, so that the threaded insert won't hold that well, but I'm not completely sure if that is really gonna be an issue. That's why I didn't make them bigger, for now at least. I'd rather have a little more plastic to push and to hold it. And the last one is going in. These other 2 screws here on the other side of the case are for the HDD SSD holder. So I'm going to turn off the soldering iron for now because we don't need it. So these 3 are for the main board. These 2 here are for the hard disk mount. So you can use it as I said, this is optional. You can just have an SSD directly on the main board and completely leave this part out. And but if you want to build something that has additional storage, or is going to be maybe having some 5 terabyte hard disk, or maybe 2, where to build a RAID, then this is going to come in handy. And yeah, but this is, as I said, this is just an optional part. So putting this completely aside, so we're not going to burn ourselves, just leaving it somewhere else for now. The mainboard size is ITX. That was one of the questions currently in the chat. And the bigger inserts are M4 and the other ones are M3. So everything that has some kind of weight or needs some rigid parts, is M4. So the mainboard mounting screws on this mainboard holder are also M4. The inserts in the bottom element for fixing the mount and also for fixing the hard disk are M4. And then the threads for the body, I'll show it to you here. These are M3, so these are 4 on the top and 4 at the bottom. So these are just M4 because they don't need to be that big and they don't hold any huge weight. So what's the next step? We will look at the mainboard mount now. We're going to fix the mainboard mount first to the bottom. So that's a little, yeah, I was thinking about like what is the right order? What could we change anything in that regard? So I figured that because of the position of the, specifically of this front screw, which holds the mainboard holder in place in the front, it is very difficult, or it would be quite impossible, I think, to mount. To first have the mainboard mounted to this holder and then attach it to the bottom. So I figured that for now it's probably just the easier order to fix first the mainboard holder to the bottom and then as the second step attach the mainboard. So let's do that right now. So we're going to use the M4 screws, and we also should magnetize the tools a bit. Let's see if there's any more questions. So let's see. I'm gonna just fix, let's put this away for a second, just fixing these few screws here. So we have 3 for the mainboard mount. Going in. Number 1. How's the audio today? Is it working? Can you understand me well? I hope so. Actually, I remember we didn't do a stream for quite a while, right? I think the last stream that we did must have been in January or even December, if I'm not wrong. I'm just going to mount it a little. Let me just turn off the microphone for a second. Should be a little better because it's just always touching my beard. I don't like that so much. It might be good, but I don't like to have it always touching my throat. So mainboard mount is fixed to the bottom element. Next thing is to fix the mainboard here, to attach it. Now the question of the day is which orientation do we have to use? And that's gonna be this is the, like if you look at this side, mainboard mount is vertical, the mainboard is going to face in this direction, or looking from the other side is going to face this direction. It is all, like this is also placed, it's not symmetrical, so it's a little back placed because of the front elements. So that's why it is it's going to be placed on this side. In the end, it's going to be touching the front panel or the I/O outlet. And how to attach it, the easiest is probably to lay this thing down and start with the top screws here. So let's look at it from the top. Probably the easiest to show it to you. So I'm starting with these two ones. We're using M4 screws for this also. They will just work fine. And these ITX mainboards have exactly 4 mounting screws, mounting points. If you're wondering, the cables that I've fixed here, this was from the previous build in the old case. Probably have to do the cabling again. I think I will still use the HDD mount. I think I had some stuff installed on that other SSD. I'm not sure 100%, but let's keep it as it was. So 2 screws go here at the top. You see this? These are the 2 mounting points. And then we have another 2. One is a little hard to reach. So that's why you should probably use a magnetic screwdriver or magnetize your screwdriver. Let's see if we can make the focus a bit better. Yeah, I think that's better. Very hard to see for you, but this screw, this is exactly why I should probably magnetize it again. Not losing the screws. So we want to make sure that we are able to find the right position down here and then fix the main board. Didn't hit plastic, hopefully. No, it's not perfectly settled yet. Now it is working. So this one and the last one. That's easier. For the ones of you that joined late, just a little explanation how this is all powered. Here is something that's called a, I think it's Pico PSU is the right term, the right word. Pico PSU, that is a mini power supply that goes directly into the connector on the main board, and it can power a main board and additional accessories up to 150 watt. There's different versions with different levels of power. So something I think is available between 100 and 180 watt. So this is just right for this main board and the lower spec CPU. And then it has a power connector and an external power supply, because some of you might be wondering, how is this all, like where's the power coming from? It is this external power supply brick. So to look nice on the table, you should probably hide this somewhere under the table, so you don't have to see it all the time. And then you have this connector, standard connector. You can see it here. This is the standard connector, just a normal power plug that goes into the counterpart of the Pico PSU. Is plugged in, and then you have 12-volt external power using this brick here. That's the last thing that we're gonna do, so putting that away for now. This connector here is what we're gonna do here. We're taking off this hex nut. I'm going to push it through the case. There is a specific hole for that. One position where this goes through the bottom, right here at the corner. I will show it to you in a second once I've done that. And it fits through just barely, so maybe we'll have to make that hole a tiny bit larger. I mean, yeah, it sits in pretty well, so it doesn't slip out at least. So this is where it goes through. There's a hole in the bottom element, and then there is a counter nut that's gonna, like, this is a bit thick, I figured, also in my tests. The bottom is quite thick, and that's why we have to push it in, and we'll probably have to make that hole a bit deeper. That's one of the design flaws still, because the original bottom element was a little thinner. At least it had a thinner ground plate, but because of the fan filter that I've attached here, I had to make the whole bottom quite a lot thicker, so everything is like equally thick, and the threaded inserts don't come out where the filter is, and that's why I had to make everything a little thicker. And that's where, like, this isn't long enough anymore, so probably have to make it a little deeper here so we can push it in into that cavity first, and then we can fix it on the other side. But for now it's sticking in pretty well, so it's not moving anymore, and should work with the power plug quite well. I mean, just in case, another solution would just to be using some glue to fix it. For now it actually looks quite elegant because it's really like completely flat, very unnoticeable, pretty much flat with the surface. But as I said, like, normally it should be coming out a little more, so we can fix it with this hex nut. But that's something that we can change in the next version. Will still work, not gonna come out. Now, the next thing is we're gonna probably use this, since we still have enough like freedom to play with the cables, and we're not having the case yet on top. We will definitely attach every cable that we can, because everything that we have to attach later to the mainboard is going to be very difficult. That's one of the downsides of this very narrow type of case, but you can imagine once this cover is on, it's very hard to reach any of the mainboard connectors. So we should connect every cable as early as possible. And for example, for the LED strip, I even decided to have an extension cable. So I'm using that extension cable for the LED strip first, and then later, when we fix the top element, I'm connecting that to this extension cable. So I have a little easier way to work with this. And the same is true for the power switch. It will be very hard to connect the power switch when the fan grill is already on the case, right? Because we have to route the cable through here, and essentially it's going to be super hard to reach the port. I mean, it's probably possible to do it because this is just right at the most top side of the mainboard, so you have a chance to reach it, and you probably can do it later. But we can also just use some jumper wire extensions and then do it later. So we just have a little more length to play with. So last thing here to mention here is on this mainboard is a little is like the connector for the fan is also very, very tiny and has a special extension here, and we can attach this additional fan that we're going to mount right now. But I think I want to fix the cables first and have it a little more elegantly bound together. And maybe we'll just leave out the SSD for now, so we have at least one less thing to do. So I'm going to fix a few of these cables on the side. The thing that you want to avoid is that you have somewhat covering this fan, or you're touching it, or some cable comes and interferes. So we should definitely try to get all the cables away to the side, not touching it. Or bound, like probably zip tying them together here on the side. Since we're not using the hard disk, we can also remove this power cable. So even less things to worry. So I think we can then just put everything down here. Connect all these cables, like just zip tie or wrap all these cables together so nothing gets in the way. Any questions so far? A printed fan guard would be a good addition. Well, good question. Probably attach something on top here, but that would be a very custom version for the specific type of fan. So I'd say if you find something that works for this specific Intel processor and this specific fan, it is probably going to be something else. And then for an AMD processor with an AMD fan, it's probably going to be a different fan guard. So, but I think it's absolutely something that you can do. Just put something on top that nothing can interfere and it doesn't block the fan. But I think like this is a very minimalistic already, so we have hopefully nothing that gets in our fan. We are also connecting finally this cable. This is the main board, or this case fan connector. And this needs to go up here. I don't have an extension for that, so I have to work with it as it is. And then finally, we can try if we can use the power connector cable or the power button cable as it is, or if we have to extend it. I think we can just try it for just a second. That's pretty easy. So which one are we going to use? I think I'm going to stick with the one with the smaller opening, because this mainboard has a flat I/O panel. It's just a little more elegant. So let's keep it like that. That's why we have two different versions of the body cover. So what I do here is I'm pushing the fan through, and we're gonna hang it outside. Well, same for this cable. And now we are pushing basically just everything that you have to do. We're gonna push the body over. And here you see, for me, that is a little more elegant solution because it's just sitting on top of the panel. And the other version it has a much bigger opening. It will work with all of the default standard I/O panels, but you will see this metal frame sticking. Like you're definitely gonna see it because it's going to be pushed into this frame. And that's why I think it's a little less elegant. But these kind of mainboards, for whatever reason, with the flat I/O panel, they are a little more expensive. Now, what else? What's happening now? I think we have a chance to attach the power button cable right here. I'm gonna try it. So we have this LED strip cable. That's not a problem at all. Put this to the side for now. And we are attaching the fan to this top grill, or this top fan mount. LED ring, or maybe we'll just first push the LED strip in. I think it's a little bit easier now. So the LED strip, how does it work? The LED strip is just a default LED strip. What you have to check is what type of LED strip is your mainboard supporting. So there is so many different LED strips. Actually, this mainboard supports 2 types of LED strips. I think the one version is where every color has its own cable. And there is another LED strip version where you have 3 pins, and it's an addressable LED strip where every LED can be addressed separately. This is a simpler thing, so it has only, essentially you can just regulate the color of the whole thing, and it has no addressable LEDs, but like in the end, the difference isn't that large. With the addressable LED strips, you can probably have some effect of the light going around the case, which might look nice, but I tried one of my strips that I had and it didn't work for some reason, wasn't working with the drivers, and that's why I'm personally going with the simpler thing, but you can do whatever you can with your main board. So what else do we see in the chat? Hey Daniel, so cool. Will the release version have the Crosslink logo embossed on it? Well, I can make a Crosslink embossed version. Actually, funny that you say it, because I have, like for the other project, I did emboss the logo here, which is of course easier and nicer with the completely closed top element. But again, then you will have to put the power button into the bottom. And that means turning on the computer is going to be done from the bottom, and you have to put the power button through here. That's why this second version exists. That's why this version exists, where you have the power button in the top lid. Still, I think you can engrave a logo here, or we could engrave a logo into the body, but there isn't so much thickness here. We have to try it out. I mean, that's why you can probably customize it to your own needs. I was also thinking about putting holes into the case, so essentially just stitching holes in the design program, especially when you have a mainboard where you have, maybe you are using RAM sticks. You're using RAM that has LEDs. So this side here where you have the CPU fan and the RAM, if you want to see that, or you want to get like an impression of the inside and still not interfere the airflow, that's one of the considerations. I was thinking that we could stitch holes. It would make more sense to have holes on this side. I mean, on the back, so you don't see much, right? There is nothing to see. But on the front, you could stitch in holes or have kind of a pattern going on here. You could have a hex pattern or just a bunch of hole pattern here. And then you would have to probably glue some transparent foil to the inside of the case, so no air is going to go out or in from this side, right? Because we want the airflow to be coming from the bottom through the whole case, take the hot air and push it out to the top. And that could be one thing that you could do to customize this to your own needs, to create some pattern here, to cut some holes here. But again, you should definitely have something closing it again, so you have the airflow still going on. I think it's pretty much customizable. You could also attach, customize the outer shell by not pushing through holes, but instead of attaching external elements and making it look like R2-D2 or whatever you might think of, right? So I think that's why it is probably there's a lot of freedom to customize it still. So Jay Christensen is from New Zealand. Hello. I think I will do my own. Yeah, why not? Nanopixel LED strips. Yeah, you can use, like, depends on your mainboard. If you want to control the LED strip from your mainboard, you have to buy an LED strip that is working with your mainboard. The only strip that I had that works with this mainboard is this simpler version. But anyways, we're going to use it. How is it working? In my case, or in this specific instance, or with any LED strip, there is a little slot here around this fan element, and you just start like where the connector is. You basically just push it in and then just go around, and you have to cut it, of course, into a length that is going to be long enough that it goes around once, but not longer than that, or not much longer. I mean, you can still have some overlap here, but not too much. And then you have to push it in. So the thing is with this one is it has this rubber. I mean, this is basically waterproof. That's why it's a little thicker, and it is a little harder to get it in. You don't have to use these waterproof versions. Of course, you can just use a cheaper version that is just I think it's also a little more flat, easier to get it in. This one has also some tape on the back, which is also not unnecessary in my opinion, and it's a little harder to get it in since that tape has already come off a little. So, and we have already used it in another case, so that's also the reason why it's a bit harder to get it in. But anyways, I mean, the slot size can be changed in any slicer, in any construction program. So you can make it thicker, so have a little more distance. That's something that is supposedly easy to change. So push it in. Yeah, this tape is already coming off. That makes it a bit more difficult to get this in. As I said, this is something that I just had lying around and was the only one that was working with my mainboard. In the end, you will have it hopefully pushed down as far as you can. So, because the idea is that this is lighting up the plastic, and the plastic transports. Yeah, as you see, this is a little harder to get it in because it's pretty thick and the tape has come off. But I think we can make it work. Anyways, you see how this works. Multiple times we can push it finally down. Yeah, probably have to make this slot a little larger, just in case that people have LED strips that are thicker than this. Even, I don't know if there's, I think we're pretty good now. I'm probably never going to be coming out again. I have the feeling that this is actually a little more tight than the original version that I had. Anyways, I think this is enough. What we want to make sure is that the LEDs are going to light up the plastic part from the inside. So the LEDs are facing outwards, and then the light's going to travel to this little corner here, to this border, and then you will see it from the outside. So just to show this to you, how this is looking in the end. We'll have this ring on top. I have to get this tape off. So the ring's going to be on top, and then this is what you see of it. in the end. It's not much, but should be enough to, like I of course tested this, but you will just see what's gonna come, like what's gonna travel in terms of the light, what's gonna travel to this corner. Okay. So it's not spectacular, but it's a small thing, small detail. And what it was used for originally was to indicate the system status. So if you use this as a server case, you can indicate probably the status of your RAID system or any kind of system error, at least to show the admin that something's not going right with this computer, that someone needs to fix something. Good. That's it for the LED. So what we're going to do now is taking the fan, mounting it. The only thing that we're double checking that the fan is oriented correctly. I think what we should do also is to fix the body. I'm pretty sure that we can still reach these few connectors here. It's hard to see here, but it's quite dark. There is 4 pins here where we need to, like in the end, we need to attach this power button and the LED. And I hope that we can still reach it. Yeah, that's probably quite difficult. But anyways, I think we can somehow make it work. So what I would do now is fix the body to the bottom elements. We'll just turn it, we just turn it around. And then there is these 4 screw holes here in the bottom where we're gonna put through our mounting screws for the which are gonna hold the body against this bottom element. Just need to get the right screwdriver. That's the one. So 4 screws go in here, and we need to make sure that we are hitting the screws. Actually, the only thing that's a little tricky in we're already doing quite well, I guess. Okay, first one is done. Number 2. I mean, you can see the threaded inserts. They are very shiny. Normally you can see them pretty well. So this is done. And 2 more to go. Okay, last one. Then if you're wondering why there's additional 4 holes in these feet, I figured that it is like depending on the mainboard fan and also the top fan, there might be some vibrations. So there is rubber feet. Like these are just 4 very simple rubber feet that we can push into these holes here. And I figured that I made the holes a little too large for these rubber feet, but depends on the rubber feet. Actually, could be that you might be using are just perfectly fine. Oh, I lost one. Wow, that's probably impossible to find now. Oh, actually I found it. So we have 4 rubber feet here, so it's gonna hopefully decouple a bit the vibrations from the table. So that's it from this side. What's left here again is this LED cable. Need to take care of that later. Then we have the fan, so I'm leaving this case just on the side for a bit. And we are fixing the fan to the LED ring. Just make sure that the airflow is going in this direction, so the air flowing up, and then we can align this screw holes. We basically have to find the right position from the top. Then we have standard, again, PC fan screws. These are normally coming with fans, like definitely something very simple. The only thing here again is where are we aligned with the screw holes is a little bit something that you have to figure by looking, or you can first put in the screw here from this side and check on the other side if you're coming out where you're coming out, and then start with the first one. The first one is always probably the most difficult one to hit, and then the other ones are much easier normally. That should be right. Yeah. Okay, so hit the first one. Then the second one is already easier. So it's not going anywhere anymore. And yeah, this is the point where we need to figure, can we actually still put the power button cable through here? Should normally work. Or I have to make the slot bigger, but it looks good. So we can push this connector cable through. I hope at least that it's still working. I mean, you could also do it before you mount the fan. We just release it a bit. Well, it's very, very tiny space here. Well, maybe I need to make that slot a tiny bit bigger so we can push the cable through a bit easier. Okay, so it is working. So here we go. Yeah, but that is probably not, I mean, that's not the easiest way to put things together. So my suggestion is, again, we could use the jumper wires to make life a little easier and have them come, like have them being connected first to the mainboard, then that's something new. I didn't try that out yet, but I think, yeah, the order of things is probably critical. I'd say we tried just the other way around first. And we have to fix it to the top element first anyways. I totally forgot about that. So let's get it out. But I think it is long enough that we can, like, we have enough room on both ends that we can then connect it to the mainboard, still have everything unassembled, and then later put everything together. So, should work. So, we take the top element, clean that hole a bit. Hopefully we can push the button through. Do we have more questions? Does the motherboard slide in and out freely? Connect all wires while it's out. Connect all wires while it's out. What do you mean by that? I'm not sure what you mean by that. Does the mainboard slide in and out freely? Well, I mean, it doesn't, if you mean whether it slides out this way, if you can just pull it out, no, because it's mounted to the bottom. What you can do is you can slide up the top element. You can take off the shell and then access all of the ports, and then you put the shell back on if you need to do some maintenance. The most tricky part is this top element, which I redesigned a bit because I wanted to have the power button coming from the top, and that was something that I wanted to test out today, whether that works and whether it is for the assembly process, if it's doable. But I figured that the hole here isn't big enough, and we need to extend it just a tiny bit, so I have to get some drill to make it a bit larger. It's gonna take me a few seconds. So that's the good thing about plastic, is that we can always rework things. At least we can drill some holes, we can extend something. It's not too hard to do. Let's see, I mean, the 10 millimeter is probably quite enough. Hopefully, it should be working. Depending on the size of the power button, you might have to make that hole a little bigger. Yeah, we'll see in a second if it's working. Yeah, there was just a tiny bit of space missing for this button, and also the problem with printing this part is that this is actually an overhang section because it is printed upside down, or basically in this direction. So this is on the printer's bed, and that means we have overhangs in this section here, right, when we print it. And that center element is also a huge overhang. Normally that's not a problem. I mean, it prints fine. You can see there is maybe some stringing going on here, but nothing that is to worry about. But the center hole can be affected by the overhang, or the fact that it's an overhang. So either there might be some plastic strings blocking the hole, so you have to drill it out a little bit. That's not a big issue. And depending on the size of the power button, this one, I think it is about 10-11 millimeters, but I haven't measured it exactly. You'll probably have to extend that hole just a tiny bit to make it go through. I think it's still not. I think there's probably a millimeter missing, so we have to enlarge it a little bit. But no problem. I mean, this is something that we can do on the fly. Give it a little more space. It's probably enough. Hopefully this is enough. Jason has a question. Cut this off. excess plastic. That's the thing, if you're working with the drill bit, there's probably going to be some plastic hanging around here, but nothing to worry. Where is the power supply? Well, as you see, the power inlet is at the bottom. I hope you can see it. You can also take a closer look from the top. This is the power inlet here, right there. And the Pico PSU has this little plug, and the counterpart is the power brick. And that's something that you have to hide, of course, because this is gonna deliver the power to your main board, and that's the only thing that's a little clunky. But if you can hide it under your table, no one's gonna see it. It's gonna keep this whole thing small and elegant. But having the power supply inside is, I don't know, I was thinking about what would need to be necessary to have a default computer power supply in such a case. But that means you have to make the case way bigger. Almost there. Almost there. What did I say? So we're just missing a tiny bit of space here. Then we should be able to push this power button through. Don't want to overdo this. Ah, there we go. There we go. This was my plan. I wanted to have the power button right here in the middle, so you can switch it on. And it is also LED, has an LED, little LED ring, which we're gonna see hopefully later. So you can see whether it's on or off. Now, the thing to do here is to use this hex nut, push it over the cable, so we can fix the power button in place. I think this is the wrong, there's a larger one here. This is the right one. So we're gonna push it over, and then we have to fix it. That's why I made this hole quite large, so we can still reach in with fingers or some pliers, and then we can fix that power button from the inside using this hex nut, this hex ring. And probably finally we have to do it to fix it like this, so it's not going anywhere. That looks good. Okay. Then here we go. We have this little, this is why I made this cutout here on the side. We have to push the cables to the side so we can, like, we're not touching the fan top, or not touching the top of the fan. I mean, theoretically nothing will happen here if the cable would touch this, but yeah, we still have to route it. Like we have this little slot here where we want to push a cable through. So the next thing to do is we have to get the cable through this little slot here. And then we have to connect it to the main board. And then we can mount everything together, not before that, because we cannot connect it to the main board later. So now cable is pushed through. I think it's now time to fix that fan. Finally using the screw here. Are we in the right position? Yes. So make sure that the cable is staying in the slot. Number 3. So you see, that's how it's supposed to look like in the end. That's how it's going to be on top. That cable goes into the slot here, and we should make sure that we push it down as much as we can later, and we probably can fix it in this side slot here with some glue or hot glue or something, or just twist it once. Maybe that is the way to do it. So have it like one loop so it stays in here. So I guess it's not gonna come out that way. So final screw for the fan, where is it? Here it is. Any more question? Will you also do some Lasten test? Lasten test. What do you mean by that? Correlating with the amount of morphed plastic. You probably should explain that question. I don't get quite what you mean. Could you make an extension for them of us who would like power supply inside? Good question. Could we put the power supply inside? I'm not sure if this kind of case is the right shape for that idea. I had an idea for a future version of this. We'll talk about that once we're done. I think we should talk about what's next with this case, because you will be able to download it, but the thing is, it's probably not perfect yet. There's probably some improvements that could be done, that should be done. Absolutely. And we'll talk about that, hopefully, today. We have enough time left. So, one thing to do here, that we don't forget that, is to connect a LED strip. I always forget about which one is the right orientation, but the 12-volt cable is, there is a little marker here, and that should be the 12-volt cable. So far, what is left to do? We have a few more screws to attach. First, there is going to be some threaded inserts that we need to insert into this fan cover, because the top element is fixed to the fan holder or this LED holder using 4 threaded inserts and 4 screws, right? They go through small holes here in the grill, so you don't see them. And they are going into the fan element, and the fan element is then mounted to the body. You will see that in a second. So we have another, like the last 4 threaded inserts. And I hope that the soldering iron is cooled down in the meanwhile. Yeah, it should be fine. So we can switch the top tip. I'm gonna switch it for the M3 tip now. And heat it up one more time. That's why I was waiting quite a while, because I wanted this to cool down. So while this is heating up, we have 4 threaded inserts, M3, that go into this fan ring. And then we have basically done everything that we need to do in terms of the soldering iron. That should be quite easy to do. So and it's already going in. Just a few seconds to do this. So one is done. That's why I like threaded inserts, like, because the working with them is actually quite easy if you have some adapter for your soldering iron. If you try this to do with the normal tip, the problem is going to be that you will probably have a very, like, depends on the soldering iron, but you might have a very thin and long tip, and that might actually be pushing far through the threaded insert and touch the plastic quite a lot, gonna melt. Like with the tip, you're probably touching plastic on the other side beyond the threaded insert, if that is a closed plastic part. That's unintended. The second problem with using a normal soldering tip is that it is very hard to align it perpendicular. So really to hold it perpendicular and insert it perpendicular is quite hard with a normal soldering iron. That's why I prefer to use these special tips. You have to check if you want to get one of those, that you have a soldering iron where they actually work. Like I figured that my old soldering iron wasn't working with this kind of tip. It wasn't a standard. There's some kind of a yeah, this front element is quite of a standard diameter, and my old soldering iron is pretty much thicker than this, and then I had to get a specific soldering iron or a new one. The good thing is that I now have a soldering iron just dedicated to threaded inserts, which is not a bad thing to have in the end, if you're doing this quite a lot. And I'm doing this like lots of times, so it's not the worst thing to have. So you mount the top fan in the right direction. Yes, the top fan is, the air is going up. So this is, like, you should make sure that the fan is pushing the air into this top element, and then the air is coming out through these grill elements to the side. So that's why the air comes into on the bottom here, where we have the filter now, going through the case, going through this top fan ring, going to the grill, and then out of the case. So moment of truth, actually, to figure how do we make the final step in assembling this. The thing left is to do here is to connect the LED, the power button, to the main board. And I think I have to look it up in the main board guide, actually, which pin is which pin. I will need to find it, because we want to have the right polarity for the switch. Let's see, addressable LED strip. So in this menu we have like two options. We have an RGB LED strip and an addressable LED strip. Some mainboards only support one type. Maybe I missed where the power switch connector is. I think it was right here on top. Hmm. $16. Ah, here we go. Why is it not explained? Here we go. Front panel header. Power switch, and power LED. Yeah, the power LED polarity is here. So Unfortunately, you can't see this right now, but I just have to make sure that I'm connecting the right cable pin to the right pin on the main board. Yeah, so this is there's also a reset switch, but we want power switch and power LED, and the plus pin is the lowest one. Yeah, that's why I said maybe it would have been a little more clever to connect this in the beginning and not now, but that's how I went, and now it is how I have to do it. So I have to find this pin. I'm sorry that you can't see it right now, but I have to, like, this is a little fiddling inside of the case. And we don't have so much light here, but I think I can do it. So first pin down, second one. The only thing that the only thing where you need to check polarity is actually the LED. The power switch itself doesn't matter which direction it's plugged in. It's just a simple switch. So I think we made it. So that's what I was saying. It's actually here at the top of the main board. It looks like it's easy to reach, but you have to exactly look it up. What's the orientation? Which pin is which pin? And now comes final phase. We want to make sure that we are not pushing any of the cables into the CPU fan. So I want to push the cables to the back side. Final stage here. It's probably the thing that is a little tricky, but looks fine so far. No cable interfering with my fan. Well, we have to make sure that it goes around, but it looks fine. And if you push that cable further in, it will go to the back side of the main board. So, final thing to do here is to fix that fan ring. These are, I think it's, how long are these? 40 millimeters, almost, pretty long. And they'll go in here. With my screwdriver. The right one. Any more questions? So far? Okay, so I think so far we are good. I want to make sure that I'm pushing down the cable as far as I can. And it came out of my little slot here. Probably glue stick or hot glue would have been the more appropriate way to fix this, but since this is just a prototype for now, I'll go with this solution. So that looks okay to me. At least this for now is good. Good enough. So again here, screw goes in pretty far. Still we can see the counterpart on the inside, and we just have to figure out where it is, get it aligned, get the screw in. And not tightening that too much, because this plastic piece is probably a little brittle if you have a screw pushing that too much down. And it's not really necessary. There's nothing. It's not very, it doesn't have to hold anything, so to say. so you don't have to fix it like crazy. Now, last two ones for the LED ring. And again, I'm pretty optimistic that we are pretty optimistic in terms of the computer working. So hopefully I'm not doing all of this and then figuring out that the computer isn't working. But it is basically everything was already tested before. But just in case, we can give it a little try to see if the power button switch works now. I'm confident because it was working last time. Let's see. Okay. So connect the power. Here is, that's how it goes in. This is the power cable. Yes, see, power button lights up when we turn it on. And you can also see that the LED strip, it is pretty bright in here, but all good so far. I would say let's turn it off one more time because I want to finalize the mount. And we want to connect it to some monitor, preferably. See if it's actually doing as expected. So I'm pushing in that cable as far as I can before I finally fix the top element. Okay. Looks good. The last 4 screws. That's hard to see, but there is 4 little holes in the top grill where these are inserted to mount the top to the LED ring. And almost there. Almost there. Yeah, so the other idea that was in the discussion, I guess that someone mentioned it in the last comments of the last video, we could also have, I definitely think that we could have a version of this top, specifically the top part, that is open to, like where the air doesn't exit to the side, but it exits right to the top. Technically, I think it doesn't make such a huge difference. In terms of the airflow, now the air comes out here at the sides of this grill. I think that I can also make another alternative version, which is basically just like having a hex grid on top, where this is like just a round corner or round border, and then on the inside we have a hex grill just sunken in a tiny bit. Question is, of course, where does the power button go then? Maybe we'll have to move it then to maybe to one of the sides here. We could also have the power button here at the front. Maybe also have some kind of display. But I mean, it's all just variations of that design. Doesn't really make technically such a huge difference. I think from the airflow perspective, it will just look different. It'll probably just a little different design. So to test out the computer itself, we can just connect the HDMI cable to one of the, let's just use keyboard, mouse and monitor cable. So USB. Looks like a bomb. Well, graphic card. I told you we're gonna talk about maybe some next iteration of this, how this could look like in the next version. Some more questions are easier mount, slide in and slide out for easier maintenance, sandwich the mainboard to fix in for space, it's a suggestion. Yeah, I see the whole, I think specifically the changing the power button to the top didn't make things easier in terms of maintenance. That's what I realize now, because you saw it was a bit tedious to get all the cables aligned correctly and then fix everything in place. I think if you do this multiple times, have to do some maintenance, you will get used to that, but it is not as easy as the original version was, because there you just had the plastic cover, you have the fan ring. The only thing that you have to take care of is the cables for LED and fan, but that's easier. Having this additional complexity with this power button on top, it looks better, I like it more, but it adds one more step to do, and that's why I say, yeah, it's not making things easier in terms of maintenance. Sliding the mainboard in and out, I think that was actually a discussion in the beginning when I discussed with my first customer, like how to do it or what could we make better. Problem with the sliding mainboard idea is how to fix that mainboard in place. You would have to have some kind of fixation from top. And the other question that came up is also, could you ship this anywhere without the problem of things moving while you have to ship it to someone? So HDMI cable goes in here. Let's see, which one was that? This was the G camera, I guess. Turning on the power. Not sure if I have, like, I don't know what about the resolution of the HDMI. That is working at all. Let's see what Windows thinks of the new output. I'm not sure if this output is working now. Let's see if this HDMI, if my HDMI card realizes that we have a new camera, so to say. Ah, yeah, actually, yes. So that's the that's the computer. Okay. Is it working? Oh yeah, we have some Steam installed. Okay, OneDrive not signed in. Yeah, don't worry. You probably have to set the resolution to something that works with the input here. Yeah, what's that? No, it's not console. Let's do something that works with. Come on, I can't see anything. Advanced scaling settings. No. What do we need? We want full HD or 4K. Okay, my grabber card doesn't like it. Maybe this one works. Yeah, this one works. 1920. Okay, that's good enough. I think that's good enough. Good. So you see the computer works. Yes. It's running. One of the tests that I wanted to do is maybe we'll turn off the light for a second so we can see the fan ring. I think maybe I broke one of the LED Maybe by pushing it very hard, I broke something in the LED strip. I'm not sure actually. I'm not 100% sure. I think from this side it's still working fine. We can turn off the light for a second to see whether this is working correctly. I think you can see it a bit now. I think you can see like the color change. I configured the mainboard software that it's always changing the ring color, and it's like basically doing a color rotation. At least I can see it on camera that it is doing a color switch in the ring. Of course, when it's very bright, you don't see that very well, but it works as it was planned to work. Still, I think I will have to find some LED strip that works with the addressable, or it is an addressable LED strip, because that would be actually a little cooler, because you can then have some like rotation effect and stuff like that. What else to say? For now, I think I'm pretty happy that it works. Computer is running, and want to get my camera back actually. Let me connect it back. So, the grabber card. It doesn't. What's strange about this card, it is always disabling the camera once you change the resolution. Now it works again. Good. What else to talk about? I think that one of the main questions that came up in the last video, and probably one of the questions that you also had today, what about external GPU or additional GPU? What about having a power supply in the case? Whether that might be this case or another additional case. That's where I will just push this out now. So I'm gonna release it on printables. Probably not tonight, but tomorrow during the day I'm gonna make some more pictures. Gonna push it to printables.com and just make a community post on my YouTube channel and on my Twitter account. And you will see it pop up there for downloading, because you can't release something on printables without pictures, obviously. And that's why we probably should take some more pictures of this whole thing. I'm just going to disassemble it in the reverse order and then make the pictures accordingly. So it is understandable what part goes, how it is connected in the end. We made this video today just to figure out if this new version is working. What could be something for a next iteration? I think either modifying this one could be one option, and probably having this additional option of a different cover here, which has airflow going out straight upwards. The other idea that I had, and you can let me know in the comments of this video what you think about it, is it's just changing the outer shape to hex. So to have a hex case or hex-shaped case instead of a round case, because that would make it possible to do the following. We could make a mainboard case that is basically this case just in hex shape. Then we could have a second of the same size or a little smaller actually, so less height. That connects to this one, and because of the hex shape, you can connect them. If you look at this bottom, you can't see it anymore. But if you have a hex shape, you can connect hex elements in several ways. So you could have like this case, and then you could have another one directly attached here, just a little less height, that contains a power supply, and then you could have a third one. So it would be like a beehive. 3 elements connected together, and that could be a little higher, so you would have like a small, middle, high case, if you can follow me. And in the third one, that's the highest one, you could have a GPU, and then the cables of the GPU or the GPU card obviously needs a PCI Express extension cable, but we could hide that because we have like at least we have 1, 2, 3 sides that are hidden of the hex. So we can have slots in that, and we can just push the cables through. So we could have the PCI Express extension cable going through the main board, through the middle part, have that GPU in the third one, which is higher, and then we have the power supply in the other one, and the cables could go like around on the inside, like right where these hex shapes touch, so you don't see any of the cables. That would be my idea. I didn't design anything yet, but it was just some thoughts and some, I was just dreaming of that, so to say, if that's possible. But I definitely wanted to have something that is capable of hosting additional parts, be it hard disks or GPU or power supply. That could be the next best iteration, I would say. But for now, like, this is what I'm pushing out, and hope to get your feedback. If anyone tries it out, tell me how it went for you. What I will also attach to the Printables website, or basically to the page where this is released, is a bill of material that contains the number of threaded inserts and the size, the number of screws of which length you need. These are the basics things, so to say. I can also put some links to the hardware that I use, so power supply, the Pico PSU, the power button, what else? Fan, okay, this is standard. The grill that I used, so the filter. So I put links to all of these things also there, so you can, like, if you have troubles finding stuff, or at least you need an idea how the things look like, you can have a look at these links. Yeah, that's what I can offer you for now. I also work, like, I will definitely create some PDF file with some assembly instructions. But I will, like, reverse disassemble this first and then just make a step-by-step PDF. Releasing that to my patrons first. And then also I thought about whether you want to support me. I think if you want to have, besides the STL files on Printables, I can also make the step files available for anyone who is on Patreon. I think that's fair, because then you can support me a little bit in continuing to develop this, and you can choose whether you just find printing this out and using it, or you want to really make some huge changes in a professional CAD software. The other option I can offer also is that if you want to use this and really print it as I did. I told you I printed this now 60 times. I'm gonna print it 20 more times. Not this specific version, but the other one, the older one, for a customer. So if you have anyone who says, hey, I want this, can you make me this in a professional way for money? I'm offering a version on Patreon where you can just enter a specific level on Patreon, a specific tier, and then you have all the rights to take this and use it, like print it for money, so to say. That's how other creators do it, like Clockspring, for example. If you just want to have like the downloads, you have like the lower tier, and if you have the like print shop, basically, if you're a print shop and you want to offer it to someone and like say, I'm charging you money for this, you can have that. But basically, STL files, anyone who wants to do it for a hobby can get it for free. Pushing that out, I will notify everyone on my community post on YouTube and on Twitter when I have done the pictures of this. So that's the least I can do to make it available, at least some images, and then you can download it. A link is going to be in the video description afterwards. So if you come back tomorrow, check the link, and that's gonna be online hopefully for download on printables.com. That's what I can tell you for now. How long have you been working on this design? I think I made the first version last year, 8 months back, based on a reverse engineering of a design that looked like this, but there was a lot afterwards, after it has been completely built again from scratch. I made probably dozens of changes because there was so many design issues with the original idea. And then I made the first version, printed that about 60 times now, and it has been used for real-world computer builds. It's going to be printed 20 more times, as I said. And then I made another iteration that I basically did a spin-off of the original. I made, again, a bunch of changes because, like, for example, based on your suggestions, the new base for taking the filter, which I think is one of the biggest improvements, like as stupid as this sounds or as simple as this sounds, but I think the filter is actually a crucial thing for long-term sustainability of all the parts inside, not getting too much dust inside, right? So that's what one important thing. Then I designed a completely new hard disk mount because the old one was, I think what was the problem originally? I don't know anymore, but I think the original one was just very hard to get the disk slug fixed. Now I made a much simpler version of this and also a single slot unit. But again, I didn't use it this time because for demonstration purpose, I think it's not necessary. Anyways, I'm still not 100%. I told you in the beginning, if you were already there, I'm not 100% happy with the mainboard mount. I want to have like the mounting points a little changed, but it doesn't have to bother you at the moment if you use it. I think it is working right now. It's just more like a visual thing that I don't like so much about it, and it has been changed so many times in terms of things have been resized, things have been moved, that I'm thinking about redesigning the whole mainboard mount or making a fresh version just from scratch. But that's details that for now don't really matter so much because it's currently working as it is. So, yeah, if you're interested in more things, builds, I can tease you a bit. I have just finished a design for a monitor desk lamp. So if you know the Xiaomi desk lamp, so if you look it up, Xiaomi monitor desk lamp on Amazon, I'm pretty happy with it. I actually like that so much that I decided, and it wasn't available anymore. So I got one unit for one of my monitors, and then I liked it so much that I said, "Oh, want to get another one?" And at that time it wasn't available anymore. Then now it costs 80 to 90 euros. I was like, okay, if it costs 80 to 90 euros now, I can probably make my own version in just 3D printed. That's what I was working on for another, I don't know, few weeks. And that's gonna be one of my next releases. So I'm gonna show you this in one of the next videos. It's also just a simple design, but at least I like it so much that I have now both on my monitors. So we'll see. Okay, we spoke about this 30 months ago. Yeah, I know it's quite some time, but I think good things have to. Anyway, it has to be tested. Like the good thing is that I had someone paying me to do the original one, and then test it. Like I tested out so many things and so many different iterations. I learned so much about getting the print settings correct for this. Like, believe it or not, this top element, so the original version, the completely flat version, it took me like 10 test sprints to figure the right print settings so that this comes out really nice. In terms of, it comes out flat, it doesn't have any bubbles or any like visible artifacts. Maybe it was just me being stupid with my print settings, but it was like I was doing a lot of different test prints just to get these parts printed out nicely, because it is a little different if you are like doing this just for yourself versus you are doing this for money and someone expects a certain result from you, and you have I mean, if you have been here for a while, I've told you that before I started this project, all of my printers were different, and when I actually started printing it in a mass production, I modified all my printers to one specific version of HeroMe with a specific nozzle, specific direct drive, and like I changed all the printers to be identical in terms of the physical parameters so that I could reliably create like dozens of prints with the same results. Otherwise, it wouldn't have been possible to print this in such a amount, right? Because if you have like 10 different printers, that's over-saturated, but if you have like so many different printers, every single printer will give you a little different result, and then you have 10 instances of this and everything looks different. Like every instance looks a little different, because otherwise you would have to say, I use one printer only for this part, I use the other printer only for that part, but I couldn't use I couldn't print out 10 bodies at on different printers. It wouldn't be feasible, or not. The quality expectation wouldn't have been met. So that's where it gets really tough. I think the learnings from this I want to share with you at some point in the future, where you exit the hobby space and you enter some kind of mid-sized business or some kind of professional business. I wouldn't call myself professional business, but I would say at least you are becoming a little print shop, and then you are entering a completely different game, because then expectations are different. You are delivering something for money, so it's not, you don't set the expectations, but someone else sets the expectations, right? So that's that's the learnings. What about heat dissipation, as that was a problem in the Macs? Well, it is not a problem with this specific combination of hardware. I can't speak for like a high-end i7 that, I mean, the thing is this, I had to go with a combination that works with the limitations of the power supply, right? And same for the customer, so they had to choose a combination of CPU, mainboard and power supply that works well together, and it works within the limitations of, let's say, 150 watt, what that power supply can deliver. And if you go for something bigger, that consumes like 250, I think what the latest i7 processor or i9 processor, like alone consumes several hundred watts of power, or 190 or whatever, or peak power, I don't know what that exactly is. You're already beyond the specification, so you will have something that creates more heat, but this is a very low spec. At least i5 processor is not totally low spec, but it's like mid spec, and it's not a Celeron processor, but it's still capable, but not consuming too much power. So that's probably why it works still pretty well without creating a crazy amount of heat. When you go higher in terms of the specifications, that's going to be the challenge. You might run into other problems. You might run into heat problems, but this one is pretty cool. But that's probably just because of this combination of hardware that I'm using, right? Yeah, anything else? If you have any more questions, I think we can talk about it anytime when we do the next stream. as I said, I've thrown some ideas here into the round about the hex shape design. I think that I'm not going to focus on that for now. What I will focus on for now is really getting this thing out of the door, so to say, that it is documented well enough so anyone can like build it on their own most of the time without any great issues, having a right bill of materials, having it documented in photos and some documentation file. And then we're moving, first of all, we're moving on to the next project. And we're probably coming back to this project at a later stage and say, okay, what's the next iteration when other things have been done? So that's when we're probably coming back to this project. But for now, for me at least, it's pretty much done. And I want to like, I'm more interested to see when you have it in your hands, maybe you're coming up with some interesting ideas about the external design, or you're making some crazy mods and making it look like, I don't know, a robot or something else, or you I'm really curious what people are going to do with it. I hope that some people are going to be using it and making their own more fancy designs, because this is pretty much very simple and clean still, and I can imagine that you probably have some crazy ideas. So let's see. That's it for today, I would say. And the name for it, oh my goodness, yeah. I mean, I called it the Trash Can PC, but it's probably not the nicest name. Maybe you come up with a name. Maybe you can do some posts underneath the video in the, not here in the chat maybe, but once we are releasing it, you can also suggest some names, or we do some kind of official poll for the name. For now, I think I've called it the what was the idea for the post on printables.com? I think I actually called it Trash Can PC Design. Well, no, I mean, I don't care so much about the name actually, to be honest. So the cross-axis computer case. Cross-axis computer case. Yeah, maybe something fancy. We'll find some fancy name for that. But yeah, if you have any suggestions, go ahead and post them on the channel or on Twitter or on Printables. In the comments of Printables, you can also like make some ideas. You can also do the remixes. I'm happy if you go and download and you do the actual print and you do the actual build. Post your build on Printables and also post your remixes if you have ideas for remixes. That would be awesome. So let's see what comes out of this, and I'll see you next time for, yeah, probably some other video about either a new project, be it the monitor lamps that I designed, or I think some 3D scanner that I'm testing at the moment, and some other projects. So see you on the channel, and we'll do another live stream on the firmware factory soon, where we are going to go through some of the configuration that you have to do for a few default printers, just to show you how that works and how you can customize it, because that was still highly requested. So I think I'm pretty much behind in terms of documentation. So we're the first thing that I'm going to do is really some live stream where we are going through some of your configurations and making them work, just to show you how this is done in general, and then you can come up with your own configuration ideas. So thanks for coming. I'm checking back on Twitch if anyone was actually watching that stream on Twitch, but I think most of you were on YouTube, and I will still stream this also on Twitch. So I'm currently streaming in parallel on Twitch and on YouTube. Just if someone wants to watch it on Twitch, you can also go there. I'm also always going to announce it on both, for both channels. And then we'll talk next time. So see you soon. Thanks for coming.